Myself, Manju, from Department of Physics, Government College, Peror. Today we will discuss phase diagram and triple point. A substance changes from solid to liquid state. The process is called melting, and when it changes from liquid to gaseous state, the process is called vaporization. In the same way, similarly, substance changes directly from solid to gaseous state. The process is called sublimation. The reverse process of melting, vaporization, and sublimation are called fusion for melting, liquefaction for vaporization, and hoarfrost for sublimation. Solids like camphor, iodine, on heating do not melt but directly change into vapor state. In fact, all solids have a finite vapor pressure at all temperature. However, the pressure is generally very small. Let us draw graph between pressure and temperature for equilibrium state between any two phases of matter. The diagram is called PT diagram or phase diagram. Phase diagram. This diagram is PT diagram or phase diagram. Let us consider PT diagram for solids which contract on melting. Example of this type of solids is ice. We know ice on melting decreases the volume, means melting point of ice decrease with increase of pressure. The curve AO in this diagram, phase diagram or PT diagram, represent the equilibrium state between ice and water and is called ice line. AO is called ice line. Since dp by dt equals L by T into V2 minus V1. V2 minus V1 is negative quantity, means volume of water decrease on melting. The slope dp by dt, the slope for ice is negative. AO is negative slope. In case of other solids, the line is called fusion line. At temperature, pressure corresponding to various points on fusion line, a substance can exist simultaneously in solid and liquid phases in such a manner that mass of substance in each phase remains constant with time. There is equilibrium between solid and liquid phase. Also, the boiling point of liquid increase with increase of boiling point increase with increase of pressure. The curve BO in phase diagram represent the equilibrium state between water and its vapor is called stream line. The curve BO is called stream line. In case of other liquids, the line is called vaporization line. This line is positive because volume V2 minus V1 in this case is positive. Thus, the slope is positive. At pressure and temperature corresponding to points on streamline, the water exists in equilibrium with its vapor simultaneously. Similarly, the curve OC on phase diagram represent equilibrium state between ice and vapor. Slope of this line is also positive. The two phases exist simultaneously for temperature and pressure corresponding to points of curve. All the three curves AO, BO and CO meet at point O is called triple point. O is called triple point. Thus, triple point is a point on PT diagram or phase diagram corresponding to the temperature and pressure under which a substance can coexist in equilibrium simultaneously in solid, liquid and vapor state. The phase diagram for carbon dioxide which expands on melting. The melting point of such solids increase in case of carbon dioxide. The melting point of such solids increase with increase of pressure. This is for carbon dioxide. If we are talking about water, melting point of ice decrease with increase of pressure. The fusion line for CO2 has positive slope. Fusion line, this axis, on this axis we take pressure, on this axis we take temperature. X axis, this is y axis, and the slope for CO2 is this. This is triple point O, this is point A, this point is B and this point is C. The fusion line AO has positive slope, means increase in volume on melting. We shall show that all points above the vaporization line substance exist in liquid state, solid, liquid and gaseous state. This slope is positive in case of CO2 and this slope is also positive. This slope is also positive. There exists only one triple point for every substance. There is only one triple point. If we want to prove that there is only one triple point for a particular substance, we shall prove that fusion line, vaporization line and sublimation line all meet at one point. Fusion, sublimation line, this is fusion line, this is vaporization line, this is vaporization line and this is sublimation line. Vapor, solid and liquid. All meet at one point. If the three lines do not meet at a point, let them meet at different points D, E, F. Consider a point inside the triangle DEF. This point lies above the vaporization line EB, above the vaporization line EB. At this point, the substance can exist in liquid state only. Again, this point lies towards left of fusion line AD. At this point, the substance can exist in solid state. Also, this point is towards the right of sublimation line, and hence the substance exists in vapor state. According to three different lines, substance should exist only in liquid, only in solid, and only in vapor state simultaneously, which is impossible. Hence, all the three lines must meet at a single point O and called its triple point. Phase diagram. It is clear from the phase diagram there can be only one pressure and one temperature where a substance can exist simultaneously. One pressure and one temperature, the substance exists in solid, liquid, and gaseous state. The triple point for water, the temperature is 273.165 Kelvin and the pressure is 4.58 mm of mercury. The triple point of water which expand on solidification is melting point at normal pressure. Triple point of substance like wax which contract on solidification is below its melting point at normal pressure. Now we will discuss about Maxwell thermodynamic relations. From first law of thermodynamics, we know dq is small amount of heat absorbed by thermodynamic system. Dq equals du plus dw. If we want to put the value of dw equals p dv, du small increase in internal energy and dv small increase in volume at pressure p. If we want from the second law of thermodynamics, dq equals t ds. If we put the value of dq in this equation, then t ds equals du plus p dv. We find the value of du equals t ds minus p dv. Internal U represent internal energy, S represent entropy, and V is volume. If we express U, S, V as two variables, X and Y, maybe any two of the variable S, T, V and P, we can write the values of du, dv and ds. The value of du equals curly u by curly x dx keeping y constant plus curly u by curly y keeping x constant. dv equals curly v by curly x into dx keeping y constant plus curly v by curly y into dy keeping x constant. In the similar way, ds equals curly s by curly x into dx y constant, curly s by curly y dy x constant. Substituting the value of du, dv and ds in the first equation, curly u by curly x y dx, curly u by curly y x dy equals t curly s by curly x y dx plus curly s by curly y x dy minus p curly v by curly x y dx plus curly v by curly y x dy. Comparing the coefficient of dx and dy, curly u by curly x y equals t curly s by curly x y minus p curly v by curly x y. Curly u by y x equals t curly s by curly y x minus p curly by curly y x. Taking partial derivatives of these two equations with respect to y and x. Curly square u curly y curly x equals curly t by curly y x curly s by curly x y plus t curly square x curly y curly x minus curly p by curly y x curly v by curly x y minus curly square y v curly y curly x and curly square u by curly x curly y equals curly t by curly x curly s by curly y y x plus t curly square s by curly x curly y minus curly p curly x y curly v by curly y x minus p curly square v by curly x curly y. Du dv ds perfect differential. Du dv ds are perfect differential. Hence curly square u by curly x curly y equals curly square u curly y curly x curly square s curly y curly x equals curly square s curly x curly y curly square v curly y curly x equals curly square v curly x curly y. Substituting these values in two equations and simplifying. Curly t by curly y x curly s by curly x y curly p by curly y x curly v by curly x y curly t by curly x y curly s by curly y x minus curly p by curly x y curly v by curly y x. Now substituting the value of x and y out of s t v and p. Put y equals v as independent variable and x equals s. Then curly s by curly x equals 1 curly v by curly y equals 1 curly s by curly y equals to 0 and curly v by curly x equals to 0. Put this value in this equation. We have the values curly t by curly v s equals minus curly p by curly s v. Now let us put x equals t, y equals v. Then curly t by curly x equals 1, curly v by curly y equals 1 and curly t by curly y 0, curly v by curly x equals to 0. Substituting this value in relation, we find out curly s by curly t equals curly p by curly t. In the same way, if we put x equals s, y equals p, we find the Maxwell equation curly t by curly p s equals curly v by curly s p. This is third relation, this is second relation. Now if we put x equals t, y equals p, we have curly s by curly p equals minus curly v by curly t at p. If we put x equals p and y equals v, we have curly t by curly p at v, curly s by curly v at p, curly t by curly v at p, and curly s by curly p at v equals 1. And the last is x equal t and y equals s. Curly p by curly t s, curly v by curly s minus curly p by curly s t, curly v by curly t equals 1.